Please start.
Yes, sir.
This call is now being recorded.
Shall I start?
Yeah, Vinayak, please start.
A very good evening and warm welcome to all the participants. This is Vinayak Somani from JC Bose University YMCA Faridabad. We welcome everyone to 6 days AICTE sponsored Atal Faculty Development Program on advanced trends for the optimization, protection and control in electrical based systems between 17 November and 22nd November 2025 in online mode organized by the Department of Electrical Engineering, JC Bose University of Science and Technology YMCA Faridabad. The coordinator of this program is Dr. Abhinav Saxena and co-coordinator is Dr. Yogendra Arya. Now we shall begin with Kulgeet of the university.
हरियाणा के अंचल में फरीदाबाद की पहचान है। जगदीश चंद्र बोस विश्वविद्यालय उच्च शिक्षण संस्थान है। हरियाणा के अंचल में फरीदाबाद की पहचान है। तकनीकी शिक्षा शुरू हुई जून 70 में। भारत जर्मन परियोजना YMCA आद्याक्षर में। कौशल विकास और उद्यमिता का सपना देखा हमने, खींची श्रम से अपनी उत्तम स्वर्णिम रेखा, स्वर्णिम रेखा। प्रगति पथ पर नित्य अग्रसर आलोक उदीयमान है। जगदीश चंद्र बोस विश्वविद्यालय उच्च शिक्षण संस्थान है। भिन्न भिन्न क्षेत्रों में प्रतिष्ठित पूर्व छात्र हैं। लोकहित कार्यों में समर्पित सुपात्र हैं। विद्या परम भूषणम सर्वश्रेष्ठोत्कोश है। अखंड प्रेरणा देते जगदीश चंद्र बोस है। श्रेष्ठ विरासत को संजोए हम सबका अभिमान है। जगदीश चंद्र बोस विश्वविद्यालय उच्च शिक्षण संस्थान है। अभियांत्रिकी, प्रौद्योगिकी, विज्ञान और मानविकी सभी क्षेत्रों में ज्ञानार्जन कर राष्ट्रोत्थान है लक्ष्य हमारा। शोध बोध और नवाचार से जग में फैले उजियारा। कठिन श्रम से शुरू होगी प्रगति की अविरल धारा, अविरल धारा। दूर करेंगे तिमिर राष्ट्र का शिक्षा ही सोपान है। जगदीश चंद्र बोस विश्वविद्यालय उच्च शिक्षण संस्थान है। हरियाणा के अंचल में फरीदाबाद की पहचान है।
With the blessings of Sir J.C. Bose, now we shall move forward. Now I invite Program Coordinator Dr. Abhinav Saxena and Program Coordinator Dr. Yogendra Arya about the briefing of the program.
Thank you, Vinayak. So, a very good evening to one and all present here. This is Dr. Abhinav Saxena, coordinator of the program, and Dr. Yogendra Arya is the co-coordinator of this program. Before I start briefing about the FDP, I'll give my sincere thanks to our Honorable Vice Chancellor, Sir, Professor Rajiv Kumar, Sir, Honorable Registrar, Professor Ajay Ranga, Sir, Professor Rajkumar, Sir, Dean FET, Professor P.R. Sharma, Sir, Chairperson, Department of Electrical Engineering, and all the teaching and non-teaching staff, J.C. Bose University of Science and Technology, YMCA, Faridabad, for their continuous support and motivation of the FDP. And I also give my sincere thanks to AICT for giving us the opportunity to conduct the FDP in the online mode. The 6 days AICT-sponsored Atal Faculty Development Program will be conducted from 17th November to 22nd November 2025 through online mode on the topic Advanced Trains for the Optimization, Protection, and Control in the Electrical Base System, organized by the Department of Electrical Engineering, J.C. Bose University of Science and Technology, YMCA Faridabad. There will be a total 13 sessions of the program, which will be given by our eminent speakers. Our speakers are belong to various reputed organizations and the industry. I'll give my sincere thanks to the speakers who take out their valuable time and share their in-depth knowledge to the participants. We have a good number of participants in the FDP, and your participations reflect our strong commitment to the continuous learning, academic excellence, and professional growth. This program has been carefully designed to enhance your knowledge, refine teaching methodology, and expose you to emerging trends in your field. We encourage you to actively participate in the sessions and interact with our resource person to make the most of this opportunity. So we look forward to your enthusiastic involvement and hope this program contributes meaningfully to your academic and research journey. So wishing you all the participants and enhancing teaching experience. Thank you.
Thank you, sir, for briefing about the program. Now I invite our Dean FET, Professor Rajkumar, sir, for addressing the gathering.
Thank you. So, our Honorable Vice Chancellor, Professor Rajiv Kumar ji, Ajay Kumar Ganga ji, our Registrar, and Chairperson of the Electrical Engineering Department, and other faculty members, those who are, and the students, good evening to all of you. So, I congratulate this department for organizing this FDP, particularly in the online mode. So, because this online mode, definitely this is the new technique and the new thing that is coming to our minds as well as in between us. So I think all the participants, they will enjoy this program, and they will definitely, I can say that they will be what I call, will be benefited from this program. So with these words, I congratulate to all the members and the faculty members for organizing this course. Thank you.
Thank you, sir, for your words. Now I invite our Honorable Vice Chancellor, sir, Professor Rajiv Kumar, sir, for inspiring us with his words.
Thank you, Vinayak. Professor Rajkumar, Dean of Faculty and Engineering Technology. Professor P.R. Sharma, Chairperson of the Department of Electrical Engineering. Coordinator of the program, Dr. Abhinav Saxena. Co-coordinator of the program, Dr. Yogendra Arya. Faculty members, those who are participating in this important faculty development program, being organized by J.C. Bose University of Science and Technology, YMCA, with support of AICT. First of all, I congratulate the department, coordinators, chairperson, and dean for organizing such type of programs, approaching central agencies for funding. And I understand the proposal of the programs are duly scrutinized over there, and only the quality proposals, they are accepted at central agency at AICTE. So my team at JC Bose deserve compliment and congratulations for submitting the proposal. And later on, I thank AICTE for giving this opportunity to this JC Bose University to conduct this program. This program is being organized on a very important topic, advanced trends in optimization, protection and control in electrical based system. I have been told many important topic covering from optimization and control of electrical based systems, ecology, smart cities, clean and green energy, quantum technologies, hydrogen energy, cyber physical system, cyber security, vast areas related to electrical engineering and how you can use other technologies like quantum and cyber security in this area are being discussed by the eminent experts from various institute of eminence. And I have been told that 13 eminent speakers, they will be delivering their talks during this 6 days FDP. I request the participant, please attend this program very sincerely. It's an evening program. You can learn a lot because this university, I recently, 2 months back, I joined this institute, this university, and I found faculty and the students and the facility here, they are world class and they are being utilized. They have, our faculty has got all expertise in all such areas which have been listed in this faculty development program schedule. So you please attend sincerely. I will also request coordinator and co-coordinator of this program, make the session interactive. Give enough time for the discussion. Whatever things our participants, those who are attending this program, they have in their mind, they should be given enough opportunity to clear all such doubts, whatever they want to discuss with the experts. So I will request them, please make these programs interactive, and so that we can make use of all the experts, eminent experts, and our participants, they can discuss their thoughts with them. So this is an opportunity for participants as well as for university to discuss and to understand what other institutions are doing. Because during discussion, you will also come to know what other faculty members from the other institutions they are doing in that area in their institutions. So this is a platform where we can learn, both sides can learn, JC Bose can also learn, and JC Bose can also tell what they are doing to the others. So I hope everybody will utilize this opportunity. With all these words, I wish a successful conduct of this program. And thank you very much. Namaskar. Jai Bharat.
Thank you so much, sir, for your kind words.
Guiding us. Now I invite our Honorable Registrar, Professor Ajay Ranga sir, for guiding us.
I think Rangaji is traveling.
Yeah. Okay, sir.
Yeah.
Vinayak, can we proceed for the next?
Yes, sir. Now I invite our Honorable Chairperson, Electrical Engineering Department, Professor P.R. Sharma sir, for the vote of thanks.
Thank you, Nick. Good evening to all. It is my privilege and honor to propose the vote of thanks on behalf of organizing committee of this AICT sponsored Atal Faculty Development Program on advanced trends for optimization, production, control, and electrical base systems, going to be held from 17th November to 22nd November 2025 in the online mode. First and foremost, I extend our heartfelt gratitude to AICT and Atal Academy for granting us the opportunity to conduct the FDP and for their continuous support in promoting the quality training and professional development for the faculty across the country. My deepest appreciation goes to our distinguished speakers who will share their rich expertise and deliver insightful sessions on the relevant topics. Your contributions will significantly enrich the knowledge base of the participants and inspire new directions for teaching and research. I am grateful to our Honorable Vice Chancellor, Professor Rajiv Kumar Ji, for his constant encouragement and unwavering support in fostering academics. Sir, your vision and leadership truly guide us to aim higher in all our academic and research endeavors. I sincerely thank Registrar Professor Ajay Ranga and Dean FET Professor Rajkumar for constant encouragement and support in organizing programs like this, which help shape the holistic development of our students. A special note of appreciation goes to our program coordinators, Dr. Abhinav Saxena and Dr. Yogendra Arya, faculty members and staff who are working constantly to make this program a success. Your commitment and teamwork are the backbone of every event in the department. To our audience, I warmly welcome you once again to the inauguration of this research-driven FDP. In these 5 days, you will witness enriching sessions on the optimization techniques, advanced power system protection schemes, intelligent and AI-enabled control strategies, real-time monitoring approaches, and emerging trends in the smart grids area. Renewable integration and electrical system stability insights gained during the FDP will undoubtedly help the participants enhance their teaching effectiveness, strengthen their research capabilities, and apply innovative approaches to solve the emerging challenges in electrical engineering. Lastly, my thanks to the committee, volunteers, and technical team whose efforts behind the scenes have ensured today's program to run smoothly. With this, we bring this inaugural session to a close. Thank you for all for being here and making this day memorable. Thank you very much. Thank you. Yes, Ivan.
So, with the permission of Vice Chancellor, sir, can we close this our inaugural ceremony? I think so. So, with the permission of our Dean FAT, sir, can we close our inaugural ceremony, sir?
Of course, you can close the program.
Okay. Thank you so much, sir, for giving a valuable time. So, with this, we close our inaugural ceremony. So, I request all the participants, please stay on the same link. So, we are about to our session 1 in the within the next 15 minutes. So, our speaker will join the session very soon, and so we will begin our session at 6:30. So, it is requested to please remain in this online mode. Okay. Thank you. Sanjay sir, am I audible to you? Sanjay sir, am I audible to you?
आ रही है आवाज मेरी?
यस सर, सर आपकी आवाज आ रही है सर मुझे।
हाँ
आपको आ रही है
हाँ,
मेरी?
आ रही है, आ रही है, आ रही है। ये स्क्रीन सेव कर रहा हूँ, ये शेयर कर रहा हूँ, वो कुछ गड़बड़ हो
सर
रहा है।
आप निकल लीजिए, डायरेक्टली शेयर हो जाएगा सर उसमें।
ये आगे क्यों नहीं जा रहा? हाँ, आवाज आ रही है आपको?
यस सर, आवाज आ रही है आपकी मुझे सर।
अभी स्क्रीन शेयर में क्यों दिक्कत कर रहा है फिर ये?
सर आप शेयर स्क्रीन करेंगे ना उस पे,
हाँ, मैं वही।
आप अपना,
हाँ,
फिर आप
वो
अपने,
ये दिखा रहा है एंटायर, या
आप
एंटायर
उसको मिनी, यस, आप एंटायर, आप एक काम करिए, आपको पीपीटी को ओपन कर लीजिए सर। आप
अच्छा,
ओपन करने के बाद स्क्रीन शेयर करिएगा। आप जब एंटायर स्क्रीन शेयर करेंगे तो उसमें आपको विजिबल हो जाएगी सर। ओपन कर लीजिए पीपीटी आप पहले।
हाँ, इसमें जो है स्लाइड मोड में, या
आप विंडो पे जाएंगे ना सर?
हाँ, विंडो पे जाऊं या एंटायर स्क्रीन पे?
आप दोनों पे दे सकते हो, एंटायर स्क्रीन पे देख लीजिए।
हाँ, वही मैं सेलेक्ट तो उसी को कर रहा हूँ मैं बार बार। इसमें तो वो नहीं दिखाता, विंडो देखता हूँ।
विंडो पे देख लीजिए, आपने ओपन कर लिया सर?
हाँ, ओपन किया हुआ है।
डेस्कटॉप पे ओपन कर लीजिए, आप देख इस विंडो पे देख लीजिए।
विंडो में तो कुछ भी नहीं आ रहा, शेयर भी नहीं आ रहा। अभी दिख रहा है आपको?
यस सर, सर
हाँ,
विजिबल है, हाँ आप दिख रहा है सर।
ठीक है।
विनायक की विजिबल है, दिखना जरा।
यस सर, विजिबल है।
हाँ सर।
विजिबल है सर वो। सर स्टार्ट करें,
हाँ
संजीव
हाँ हाँ।
sir. Okay, so a very good evening to one and all present here, to all the participants. So welcome you all to this session one of this day one of the Atal Faculty Development Program in the online mode. So today we have with us our speaker, Dr. Sanjay Yadav sir. Dr. Sanjay Yadav sir obtained his master's degree in MSc in 1985 and his PhD degree in physics in 1990. Presently, he is working as editor-in-chief of MAPAN, Journal of Meteorological Science Society of India. He is also the vice president of Meteorology Society of India, MS New Delhi, as well as the vice president of the Ultrasonic Society of India, USI, New Delhi. He is the former chief scientist and head of psychomechanical meteorology division of NPL, and also the former professor at the Faculty of Physical Science, Academy of Science and Innovative Research, ACSIR, HRDT Ghaziabad. He has taught advanced measurement technique and meteorology courses, taken practical classes, and supervised graduate, master, and PhD students since 2011. He is recipient of several awards and scholarship of national and international debut. He significantly contributed to the field of pressure meteorology, biomedical instrumentation, ultrasonic transducer, and instrumentation system. His current research interest includes the research and developmental activities in physiomechanical measurement, establishment, realizations, maintenance, and upgradation of nasal pressure and vacuum standards, disseminations of nasal practical pressure scale to user through apex level calibration training in consultancy services, inter-laboratory comparison, proficiency testing, program and key comparison, implementation of quality system in the laboratory as per ISO IEC 17025 standard, and finite element analysis and Monito Carnot simulation for pressure balance. He has published more than 500 research papers in the national and international journal of report and conferences, 25 books, 17 patents and copyright, supervised 13 PhD students, and drafted several project, scientific, technical reports, document, and policy makers. Thank you so much, sir. So this is Sir Abhinav Saxena here, from coordinator of this YMCA JC Bose University. So I welcome you, sir. Over to you, sir.
Thank you, Professor Saxena. I am really happy and glad to share my experience with you people, and my hearty congratulations for organizing this wonderful event. I must thank the organizers, JC Bose University, the whole team behind this organization, especially Dr. Arya and you. So now, not wasting much time of mine, I concentrate now on what is the role today I have been assigned. So my talk will be on role of meteorology in nation building, and with this special reference to Viksit Bharat 2047. Dr. Saxena, in any time in between you feel that my voice is not coming or breaker, you please let me know.
Sure, sir. Sure, sir.
Okay. So whenever I start giving talks on meteorology, I normally quote this quotation, which is written downwards. We find no sense in talking about something unless we specify and how we measure it. A definition by the method, by measuring a quantity, is one of the way by avoiding talking nonsense. So it's a beautiful talk. Until unless we measure something, we cannot say perfectly what is the quantity. Not going ahead. Yeah. So my talk will be normally focused on India Vision 2047, and then the role and impact of meteorology, measurement and meteorological aspect, primer of industrial revolutions, global meteorological trends, future of meteorology, and international linkages of metrology and national measurement system and its role in national growth. So if you see the particular this slide, you will find that how much our potential in this field, and you can see perfectly this data from the Government of India website. So per capita GDP in US dollar term, if you see for the 2047, by the current rate, you can see by the Mool mantra given by our Prime Minister Narendra Modi ji, using the 3D for Vision 2040, that is diversity, demography, and democracy. So altogether, this vision for 2047 and this in US capita, the 2014 is over 25,000 US dollars. So national GDP is growing at the rate of 12%. If you consider from 2021-22, and by that rate, if you assume this will be a tremendous potential in India. Similarly, the potential growth, this population growth, is slightly decelerating at the rate of 0.01% after every 5 years. So this is another important aspect in this exchange. So exchange rate is also slightly improving versus dollar. Indian rupees is slightly improving since last 2020-25. So all these all together, that's this dream of achieving highest GDP is not far away. I don't know why it is again. Yeah. So now, if you see the different indicators by the Niti Aayog, you will find that in GDP at the current price, if we count in trillions of dollars in 2030, 40, and 2020, it is going to be roughly $30 trillion. So per capita GDP at current price is also will be from 4,418 to 17,519 in 2047. Export and import, you can clearly see the growth rate is tremendous, and in case of the investment and saving, it is also a very, very good potential. And now, one of the important mission by the Government of India is National Quantum Mission, where metrology is playing a major role. So this National Quantum Mission is basically aims to put India among the top 6 leading nations involved in R&D. You see, only few countries are involved in this quantum mission, like US, Canada, France, Finland, China, and Australia. So this is a very good initiative by Government of India, and the nodal Ministry of Science and Technology, and the major highlight is a thematic-based hub, to develop thematic-based hub. So that is in main 4 themes are selected, that is healthcare and diagnostic, defense, energy, and data security. So using this a huge boost in national priorities for various schemes of Government India, like Digital India, Make in India, Skill India, Stand Up India, Startup India, Self-Reliant, and Sustainable Developmental Goal. So quantum mission is basically on the two quantum phenomena, that is quantum superposition and quantum entanglement. So if you study these phenomena altogether, you will find several quantum technology which can be newly developed, or existing technology can be improved, which is top bottom. You can see various quantum technology can be developed using by this support of the quantum mission. So role of metrology in quantum mission is obviously you will find metrology everywhere. I will be discussing this later on. So metrology, how the smart vision 2047, metrology plus quantum technology form backbone for innovative lead development, securing India's position among advanced industrial nations. As I pointed out, 6 countries, from accurate timing system to ultra precision sensors. This dual focus is strengthening sensor like banking, strategic defense, healthcare, climate science, and industrial automation. Precise measurements boost consumer trust, trade, competitiveness, and scientific excellence. So this can be achieved through metrology, different quantum technology, and accordingly precise sensing and various applications, as I mentioned. If you see the focus of Government of India, Dr. Jitendra Singh, our Honorable Minister of Science and Technology, he highlighted India's roadmap in metrology in Asia Pacific region 2024. Recently, this event was held in NPL, New Delhi. And as a leadership in metrology, Foundation for Quantum Innovation, he said that the Foundation for Quantum Innovation, Industrial Quality Export, and Viksit Bharat 2040 ambitions. So that way, the National Quantum Mission will play a vital role. So quantum sensing and metrology vertical is one of the verticals in a quantum mission. And in this metrology, one of the 4 pillars alongside computing, communication, and materials in that particular vertical. Department of Science aims to develop ultra-precision quantum sensors, that is magnetometers, atomic clocks with functional stability of 10 to the power minus 19 for navigation, timing, and healthcare applications. Now, if you see what are the deliverable for this quantum mission in 2000 up to 2030 and 31, in quantum computing, they expect to have 52,000 qubit quantum machines. Quantum communication, secure 2,000 kilometer network via satellite and fiber. Quantum sensing and metrology, magnetometer, as I pointed earlier, magnetometers, atomic clocks, and extreme precision sensors. And then quantum material and devices, if you go by the photon sources, quantum materials for devices, and then forecasting meteorology, high resolution 6 kilometer grid forecasting, and weather infrastructure, large scale hyper local monitoring of agriculture, and for this safety. Now, if you go by the metrology is basically needed in the fabrics of any country. So if you go by the metrology for science and technology, so science and technology is needed in the fabric of science and technology. It is, please understand, last slide I particularly emphasized on the meteorology. So metrology and meteorology are 2 terms separately. Please do not confuse. Normally people send me paper also, they write paper on meteorology, considering that it is meteorology. But metrology and meteorology are entirely different. Meteorology is a science of matter, and but metrology is science of measurement. You can have metrology of meteorology, but not vice versa. So please understand this clearly. So man is the measure of all things. That was called by Pythagoras, and that way this metrology in everywhere. If you see the impact by 2047, the growth in metrology is expected at the rate of 9%, and it will be by 2029. It is expected to increase around 17 billion, and in 2014, by this rate, again around $30 billion. So that is enormous. And this drives the researchers, scientists, academicians to work together to achieve these goals. If you see the optical metrology market, you can see, consult this particular slide. Optical metrology section is increasing at the rate of almost 5%, and it will be 5.13 trillion market. And similarly, in market dynamics, you see clearly increasing. And for particularly see various equipment, this downward slides, you can see a different instrument which are going to dominate in the near future. So coordinate metrology, coordinate measuring machine, measuring instrument, automatic optical inspection instrument, 2D equipment, optical. That is a long list you can find, and the potential is clearly visible. So this slide gives you some picture from 2021 to 2034. And similarly, the calibration requirement is continuously increasing, and the same is the case for the service sector. So these slides, you can clearly find how much potential is there and how much revenue such system can generate. For example, optical devices in a right hand or top column, top right hand top slide, and similarly the CMM machine. So few examples are there: healthcare, automotive, electronics, and aerospace in terms of revenue. Journey towards developed India, if you see this particular GDP is increasing. Currently around 2 trillion, so it will be expanding exponentially. So you can see this particular side, and our population is increasing with a slight deceleration rate. Similarly, this particular side, if you see this population by 2047, poverty line improve, decreasing. This slide you have already seen. So now I come to the measurement point of view. What is measurement? Is basically a process of determining the value of physical quantities, such as length, time, temperature, pressure, and electrical current. These measurements can be either direct or indirect. Direct measurements are made by comparing the quantity being measured to a standard unit of measurement, such as a ruler or thermometer. Indirect measurements are made by using other measurements and mathematical formula, like in case of thermal properties of materials and so. And each measurements are subject to uncertainty, which can arise from a variety of sources, including limitation of the measuring instruments, variation in the influencing quantity being measured, and skill of the person, and precision of the measuring instrument. So all these will affect the uncertainty in measurement very important aspect. Measurement is nothing without uncertainty. So you have to assess the uncertainty in measurement together. Now, particularly for the young people, there are two types of measurement: scientific measurement and metrological measurement. So what is the difference between scientific and measurement? You every day you perform thousands of measurements, so that are made to understand a specific scientific phenomena or concept which you are doing daily. So they are often used in research and experiment to gather data, and which can be analyzed to support or disapprove scientific theories. Scientific measurements are usually made with instruments that are specifically designed for a particular measurement, such as a thermometer for measuring temperature or spectrometer for analyzing composition of light. But how the meteorological measurements are different? So meteorological measurements are made for the purpose of ensuring accuracy and consistency in measurement. I told in a previous slide that every measurement is associated with certain uncertainty. So that way the measurement made purpose of ensuring accuracy and consistency in different setting and instrument. So metrology is the science of measurement, and it is involved and development and use of standard unit of measurement instrument that can measure those units accurately, consistently. Meteorological measurements are used to ensure that measurement made by different people at a different location by different instruments are compared and understood and consistent. So that way meteorology is different than the everyday scientific measurement. In summary, while scientific measurements are used to study a particular phenomena, meteorological measurements are used to establish a common language of measurement to ensure that different measurements can be compared and understood. Whenever meteorology in nowadays for sensor technology, quantum, and this mission, mechatronics is very, very important, which is the field that combines mechanical engineering, electrical engineering, computer science, and to design and control advanced systems. Often involves the use of sensors, actuators to detect and respond to changes in the environment, as well as control algorithms and software to perform complex tasks. So system can be found in a wide range of applications, including robotics, aerospace, automotive, and medical devices. And these particular field you have already seen in quantum mission. Why meteorology important? Meteorology important basically, sorry, it increases knowledge, it protects people, it governs transaction and improve quality. So that meteorology is very, very important. Now I slightly give a bit about the industrial revolutions. So our first industrial revolution is basically was on mechanization, second revolution on electrification, and third industrial revolution was automation and globalization, and the fourth revolution which is at the big slight end is digitalization, and the fifth revolution is personalization, and now sixth revolution has started 2 years back at the time of Corona. So fourth, fifth, and the sixth industrial revolutions are going neck by neck. Slowly, the fourth revolution will be converted into fifth advanced revolution, where personalization is main focus. And in sixth industrial revolution, there are several other facts. So what are the meteorological challenges in coming years? So this slide gives a little bit idea. So first industrial revolution was the birth of the industry. Second was precision engineering and mass manufacturing. Third was automation and electronics. Fourth was the fusion of digital innovation and manufacturing excellence. And fifth industry revolution, I said previous slide, personalization. So that is human-centric collaboration and metrology's evolution. And then a sixth industrial revolution is the future, and that is future of manufacturing. It is a need-based manufacturing, need-based manufacturing. If you go by the neck-to-neck different revolution, so one big part of this whole revolution was metrology, which did not do credit to zero, but it played a major role. And some gears were like the powerhouses behind everything from loom, power looms later on, and but making handmade looms, and then it becomes steam power and power looms. Then comes the precision engineering and mass manufacturing using assembly line, and this electric power was invented, and that way this ever present integration of energy revolution manufacturing strategy permitting exceptional scalability in working equipment. So extensively, this period witnessed the inception of electrical vehicles, propelling business equipment, mainly gears, which performed a pivotal function in augmentation of efficiency and skills of factories. So I'm not going to read the whole, but because I have to speak a lot of slides, so I will be going a little fast. Then industrial 3 revolution computers were introduced, and several automated processes were started in this, and electronics improved extensively. So the introduction of laser scanning devices during Industry 3 revolutionized metrology. Laser scanners provided non-contact high-speed measurement capabilities. This is basically Industry 4. Industry 3 is wrongly written, left-hand side. So the in Industry 4, cyber physical systems was introduced. IoT and networking was the main focus in this revolution. So integration of IoT into machine instrument enable collection of extensive real-time data, smart sensor integration into machinery and measuring instrument, consistently oversees the record intricate details and performance indicator during manufacturing process. Following this, collected data undergoes analysis via AI and machine learning algorithm. So this is Industry 4, and then Industry 5, which I will read a little bit extensively because this is the current state, which Industry 5 script a crucial segment in the area of industrial revolution, engaging solid prominence of human-robot association. So it is a human-centric collaboration with the metrology evolution, and then precision of human-machine collaboration, quality introduce skill enhancement and training. So that way, very, very important. So the focal theme of Industry 5 involves around expanding human competencies, leveraging high-tech development. So focus here itself is on skill enhancement and training. And then archetype swing brings out a new breed of manufacturing, while tasks are optimized to capitalize on the unique strength of both human and machine. So this collaboration of human and machine is giving a boon to this revolution. There are many aspects of Industry 5 in human-machine collaboration, quality and safety, adaptive and responsive manufacturing, skill enhancements and training. As I pointed out earlier, So I will a little bit say about adaptive and responsive manufacturing, because some of the people are maybe involved in this aspect. So in this case, it enable manufacturing process advanced tools equipped with AI and machine learning capability contribute to development of self-calibrating and self-optimizing system. So these system can adapt to changing condition in real time, ensuring continuous precision and efficiency in manufacturing operation. And being calibrating and testing online these process give very, very good adaptive and responsive manufacturing and ensure quality in the product. Then comes the last industrial revolution shift. That is six is a future of manufacturing, where it is ubiquitous, demand-driven, human-centric, autonomous, robotics, and it basically anti-fragile digital twins and 3D adaptive manufacturing introduced. So quantum computing, hyper-connected satellite communication are its major component. So it gives role of metrology industry 6 in quantum leap in manufacturing, nanotechnology, precision engineering, AI and automotive systems, biotechnology, and sustainable manufacturing. So industry 6 envisages a systematic relationship between human and machines, allowing them to work together. These are the important aspect in this quantum leap in manufacturing, nanotechnology, and precision. Very, very important. So I will read only industry point of view, role of metrology in industry 6. So it assumes a paramount position with the context of industry 6, given the escalating complexity of manufacturing process and their growing reliance on nanoscale precision. So metrology emerged as a linchpin responsible for upholding the precision, reliability, and quality of products. Its evolution towards the nanoscale measurement is imperative and guarantee accuracy of the atomic and molecular levels. So quantum measurement, characterized by unparalleled precision, herald a transformative era in quality control and material characterization. So this way, at the landscape of manufacturing process into the future, the evolution of metrology stands as a key determinant for sharing and safeguarding the integrity of product and process within this technological advanced industrial field. What is next? After Industry 6, the course of industry advancement and technological integrity stands as a manifestation of humanity' persistent pursuit of advance and optimization. So positioned at the brink of so-called Industry 6, the contemplation of forthcoming development elicit both excitement and complexity. The transition from conventional mechanical component to digital precision in metrology represents a noteworthy odyssey, yet the prospect of future hold the potential to once more revolutionize the landscape of manufacturing. So in 7.1, you can find the advance in gearing technology. This is only one example I have prepared. It is not only focused on gear, but for giving you some example. So advent of Industry 6 anticipates momentous advancement in the realm of gearing technology. Nanomaterials, exemplified by carbon nanotubes and graphene, exhibit the prospective capability of transform the landscape of gear design and manufacturing. These materials manifest extraordinary mechanical robustness, durability, and distinct molecular level properties, thereby presenting the prospect of the gear characterized by unprecedented lightweight, heightened strength, and enhanced efficiency. So therefore, quantum mechanical principle may also find application in gear system, potentially unlocking level of precision and performance hitherto unparalleled. So more stride in additive manufacturing methodology exemplified by 3D printing is tend to facilitate the realization of intricately customized and sophisticated gear designs while minimizing material wastage. So very, very important this revolution. And in digital metrology, you can find this augmented reality and virtual reality have the potential to further transform metrology by furnishing immersive and intuitive interfaces for measurement, inspection, and quality control procedures. Then cyber security in Industry 6 is a thoughtful adaptation because whenever you go for an enormous and huge data, cyber security is very, very important. So IoT ecosystem will undergo expansion, fostering connectivity among devices, sensor, machinery. So this growth will establish an inclusive data sharing network, enabling advanced decision making in the engineering field. So smart factories are poised to dominate and function cohesively, leveraging consistent machinery system and engaging AI processes to augment production process, anticipate maintenance requirement, and dynamically adjust to evolving demands. So that is just cyber security. Then sustainable or eco-friendly manufacturing. Now focus is on this. A noteworthy ascent in Industry 6 would be sustainability and eco-friendly manufacturing practices. Integration of green technologies, renewable energy sources, and eco-friendly materials would have a shift towards more environment-friendly production process. As for example, gear metrology innovations are expected to make a paradigm shift, enabling the formation of energy-efficient equipment, techniques, and method to minimize waste and reduce the environment impact of manufacturing operations. And this last ethical consideration is very, very important whenever some new technologies are adopted and the humans are involved. So the past revolution of gear metrology is sprouting from simple tool to modern day cutting edge technology is piece of clear evidence of human ingenuity. As we are at the gate of entering Industry 6, the futuristic vision of manufacturing process would provide more efficient and precise solution for sustainable, adaptive, self-regulated, ethical principles. So achieving such a vision requires a considerate incorporation of technological innovation, ethical consideration, and unwavering commitment to leveraging the advancement for the collective betterment of the society. Now, in 2014 Vision for Developed Nation, India at 100 years of independence, achieving global leadership in technological manufacturing sustainability, emphasis on Atmanirbhar Bharat, and metrology as a key enabler in defense, space, health, infrastructure, and digital technology. So these goals are not mine. Government of India has envisioned these goals, and we have to achieve these goals. In development, if you see, it supports high-tech manufacturing, quality control, and international trade. It enhances the competitiveness of Indian products globally. Infrastructure development, precision measurement in construction, transport, and energy sectors, ensures safety and efficiency in a large-scale national project like smart cities and high-speed railways. And in manufacturing, you see the precision measurement, pro quality, and reduce waste, integration with the smart manufacturing system with real-time monitoring, healthcare and biotechnology, accurate medical measurement ensure patient safety and better healthcare outcomes, support advancement in biotechnology, pharmaceuticals, and medical devices, and in space and defense, crucial for the development of advanced aerospace technology, ensure the accuracy of satellites, missiles, and defense systems. And in metrology, in environment, it supports measurement in air and water quality, aiding in the fight against climate change, ensure the precision of renewable energy system like solar, wind, and other sources, energy efficiency in smart grids, metrology enable smart grid and efficient energy consumption, while vital for optimizing the use of renewable energy sources and reducing carbon footprints. And if you see the United Nations Sustainable Development Goals Vision 2030, you will find that in various goals, two important goals, Sustainable Development Goal 3 and Sustainable Development Goal 9. Metrology is in the fabrics. So you see this universal health coverage will be integrated to achieving Sustainable Development Goal 3. And in metrology for industry, innovation and infrastructure is the Sustainable Development Goal 9. So it is basically build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. So this is a BIPM slide. This is not mine slide. These are the objectives. So, but I will read downward quotation at the end where it is clearly written that you cannot discover, design, build, test, manufacture, prove, buy, operate safely and reliably without proper metrology. So that is the impact of metrology in every aspect of our human life. So global competitiveness when we have to face, so metrology ensure Indian product meet international standard, enhancing trade, facilitate participation in global market through conformity assessment and certificates. So innovation and R&D encourage research in cutting edge technology and support India's goal of becoming leader in global innovation. So if you see our global trade, how our global trade is organized by World Trade Organization in metrology, which is WTO is the international organization which deals with the global rules and trade. And you might have heard about the GATT. What is basically GATT? GATT is the General Agreement of Trade and Tariff, which is now the WTO principal rule book. So GATT is a principal rule book for governing the trade in goods. So implementation of trade agreement under the WTO require extensive and internationally recognized system, comparable and traceable measurement. So again, metrology part is here. Government initiative for metrology development is a different part. Bureau of Indian Standard, its role in maintaining and developing measurement standards. Partnership with industry to establish new benchmark for the future. And MPL contributes to research and innovation in metrology and role in international collaboration and standard development. And legal metrology major role is to enforce law and make law. Now comes to the current trend for Viksit Bharat, few pathways for Viksit Bharat 2047. So current trend and need, I will show in a few slides here. If you see this green one is the current trend, and blue one is the investment required. If you see the current rate, if you see that investment requirement is also continuously slightly reducing, because as a country move towards a developed nation, so such requirement automatically going a little bit down. At the current level, it is slightly high, but slowly it will be lesser. If you see in a different outlook, you can see this also current trends, green one, and investment requirement in 2047. Investment in telecommunication sector, same outlook you can see, same way it is going. Investment in energy sector, again, some of your people involved in energy sector, they can consult this particular slide. This is percentage in GDP, current trend, investment trend in water resources. So in manufacturing, service, infrastructure, and agriculture. So if I take the agriculture, it gives agriculture business, food processing, food safety and nutrition, agri-technology, agri-machinery, aquaculture, and many more. And in infrastructure, you can have energy and renewable energy, roads, highway, port and shipping, telecom, electric mobility, public-private partnership, and many more applications. I can give numerous applications. In sustainability for circular economy, you can have sustainability award, green buildings, clean air for better life, water management, energy sustainability, and sustainable reporting. So this is a particular slide you can see by the government of India. It's the period in the history of India when country is going to take a quantum leap. For India, this is the time, right time. Yahi samay hai, sahi samay hai. We have our freedom struggle as a huge inspiration when the national efforts got concentrated to one goal, independent. And today, the aim of your goal should be, your resolution should be only one developed India. Youth power is both the agent of change and also the beneficiary of changes. So the roadmap of progress will not be decided by the government. It is alone, but the nation, Viksit Bharat, has to be built only through Sabka Prayas, Sabka Bharat. So if you go by the sizing and the pricing, where will the value gains come from? This particular slide of PricewaterhouseCoopers, you can consider this downward dark red is labor productivity, and then upper red is personalization, and then further time saved, and yellow is the quality of product. So metrology in digital India, in smart cities, major role of IoT, accurate measurement power of IoT enabled devices in smart cities, enable energy usage devices in smart city, enable energy usage, waste management, and urban planning. Digital economy ensures security and trust in digital transaction through precise data measurement. It supports innovation in AI, machine learning, and big data analytics. So India in 2047, vision of a developed nation is India's projected GDP growth, population trends, and the technological advancement. So a bar chart showing India's projected growth, you can see now. So projected growth in 2047 in comparison to other countries. If you see, India is down yellow, upper one is USA, and middle one is China. So slightly in the coming days, India will surely catch up these countries. But they are also fast moving. So we have to make our continuous efforts. If you see by the contribution in metrology, different sector, 20% defense, 15% digital economy, 25% healthcare, and 35% manufacturing. So manufacturing is having tremendous potential, and the rest of the other field 5%. If you see Indian demographic case, you will see this downward youth under 30. You can see, and the middle one is working age 3 to 60, and senior people 60 plus upper one. You can see this upper one is almost constant, and these we have to keep all these things in perspective while going for the developed 2047. If you see the investment $1 billion requirement in 2030 and 2040, the same rate, it will प्रज्ञा मीटिंग में हूँ 2040 the investment requirement is almost $100 billion. So global sensor market, if you see, you can consult this particular slide. Biosensor segment is predicted to dominate in 2032 by technology. CMOS segment is considered. And the driving factor of the sensor market are the increasing demand of surveillance, cameras, consumer electronics, indoor navigation application, high accuracy motion sensor in video games, and rising adoption of green energy technology. So this is very, very important. So this sensor market is growing 8.2% annually. And this market will be $5 billion around, from around $3 billion at the current situation. If you see the meteorological market, it is again $11 billion in 2020 to $15 billion in 2027. Increasing meteorological advancement and all this at the rate of 6.1% annually. So this market is huge. Global surveillance meteorology market, Europe, Asia, Middle East, the comparison, you can clearly see the whole market is increasing almost 7% rate. 3D market, again 8% growth. It will be 11.2 billion to 16.4 billion in 2028. NDT and inspection market, huge, almost doubling from 10 US billion dollar in 2000 to 18.5 in 2028. Magnetic sensor from 4.3 billion in 2020 to it is already achieved. This slide is this already achieved 7 billion. Pressure sensor, again increasing tremendously. Sensor market, if you compare by digital adoption rate and percentage of growth, so you will see India in both front of you will find a huge potential in India in comparison to other countries. Right hand side is the smart building, where lot of thousands sensors are installed in these buildings, and that's why this technological advance and metrology requirement. Healthcare advancement driven by metrology, where it includes biotechnology, medical device, pharmaceuticals, and precision medicine. So all increasing. Challenges ahead. So technological advance need to keep pace with the rapid technological growth in field like AI, space, quantum technology, And accordingly, we need enhanced infrastructure development of world-class meteorological labs, training and skilled workforce, which is a requirement in Industry Revolution 6 also, and related sciences. So in science and technology, critical in scientific research and advancement, facilitate global collaboration, precision in medical device, accurate precision in diagnostic and devices, plays crucial in pharmaceutical, biotechnology, public health, and all this. And then in medical devices, the government of India is investing a lot of money. This particular slide gives few glimpses of these. Medical device in India, market surveillance, and all this initiative by government of India. 37% CAGR. Again, other medical devices, equipment, food processing equipment, and other devices. Projected growth of IoT devices, you see the exponential growth in 2014, crossing $70 billion. Projected share of renewable energy, again, manufacturing industries, investment in space and defense meteorology, touching around 300 billion US dollar. Smart city development in India. Currently, we are less than 100, but it will be going 300. Carbon footprint we have to reduce to almost zero in coming days. So at the moment it is too high, but slightly we have to come to the zero level. Export growth of high precision goods increasing. Skilled manpower. So whenever we go to development, you see we have to have a skilled manpower. That's why this academic institution, other institution, they have to develop some workforce in these fields. Current is 1 lakh worker to 5 times, 10 lakh worker to 5 times. Energy efficiency in smart grids. You can consult this slide. Energy efficiency requirement. This is already done. The future of AI, prevention and cyber security, objection detection and classification, automated geophysical feature detection, text quality of imaging, object identification, detection, classification, tracking, predictive maintenance, efficient scalable processing and patient data, algorithm trading strategy, static image recognition, classification, and everywhere you will see the enhanced potential. IoT, I have already shown earlier. So digital technology have involved 2 days tipping points. Already covered. So now this we are moving up from different industrial revolution. Digital twin simulation and virtual reality and augmented reality is a future. So we have to focus on this aspect. In the healthcare sector, again, you have to have in the health 1, 2, 3, 4, and 5. So currently we are at the customer-based model. So where strategic differentiator, lifelong partnership, customer well-being and quality of life should be the focus. And this particular slide by devices and all this, if you see this, yellow is the future scenario, green is emergent emerging and future accelerator, mix of blue and green, innovation accelerators, and blue and science and technology requirement. You can see particular technology and their growth. And you see, as I pointed out, when we go for the sustainable development goals, our population is slightly decreasing. The worrisome is that I always feel this worrisome because our societal values are collapsing at the rate of 30%. With development, I don't know, is it correct or but I always throw it to the audience to decide how to tackle this, but it is happening. The evolution of human development and their societal collapse. So sensor and this market I have explained clearly. Then calibration, where calibration is required. Calibration ensure reliability and measurement, ensure measurement results are consistent, compliance to regulation and standards, ensure safety and avoiding accident and failure, improve quality control and credibility, increase efficiency and reduce downtime and cost. Now the question arises, what is the need of calibration? Normally people say this equipment is American made. We have bought it 10 years back. It is perfectly working. It's not perfectly working. It should be accurate, reliable and consistent. Whether you have checked the consistency, the measurement made in 2 years back and measurement made today are consistent? No. That way you have to have this calibration of the equipment. So when making decisions, it is important to know that information is dependable, reliable, and even when it is collected over a period of time or by different operators. Also, location should not impact the measurement readings. So calibration are needed to ensure consistency. The measurement made by the equipment in Faridabad should be reproducible by the different person in Delhi under the same identical influencing conditions. Once an instrument is calibrated, it must be cared for in order to regain the calibration. If instrument is repaired, it should be again calibrated, because when instrument is repaired, its calibration is shifted. So you have to recalibrate it. Also, the device should be monitored to make certain that calibration remains steady. This is achieved by checking the accuracy of the instrument, determine the traceability of the measurement, SI unit of defined intervals. This we can leave. Traceability is needed in when calibration is performed. The traceability is the major requirement which is required for the quality and assurance, safety and compliance, winning customer trust and satisfaction and confidence, transparency and continuous improvement, risk management, and increase efficiency, reduce downtime and cost. So why metrological traceability is important? So metrological traceability is important because it gives confidence and assurance that your measurement results agree with national standard, international standard 17025 within the statement of uncertainty in measurement. So you have to have a standard procedure, you have to have a measurement uncertainty, and then only you have confidence and assurance in your measurement. So without metrological traceability, a laboratory can claim anything they want in a test or calibration report. With metrological traceability and the independent verification for an accreditation or inspection body, you can minimize the risk of falling victim to fraudulent information and activities. So this is the unbroken chain traceability goes from SI units to downward to primary standard, secondary standard, working standard, and instrument used at the user level. So these, if this chain is broken, your measurement is broken. So you have to maintain the traceability of your measurement. So impact of measurement, I already explained. I need not to give each and every aspect, but I can read at least one environment. Metrology also used for monitoring and managing environment. Accurate measurement are required monitoring air, water quality, climate change, and natural resources. Similarly, impact of metrology in economic benefit and societal benefit. Economic benefits are reduced distribution and transaction. पेट्रोल पंप से पेट्रोल ले लिया और पैसे उसने ज्यादा चार्ज कर लिए, मीटर ठीक नहीं है, तो हमें डिस्प्यूट होगा, हमारी लड़ाई होगी. So in order to reduce disputes and transaction, water bills and other bills, consumer protection, level playing field, electric effective stock control, control of frauds, full protection of government excise and taxes, full national benefit commodity export, support for global trade in measuring instrument, increased compliance, sound equivalent basis for the measurement, benefit of the cost of metrology regulations, and international organization of legal metrology compliance. And in societal benefit, you can have support to society, technological education, reduction of death and injuries, accidents, improvement in natural environment, improved health and standardization, confidence in measurement result in area related to health, safety, and environment, knowledge and data generation, academic expertise creation through support of PhD, masters, graduate dissertation, skilled manpower through training, awareness program, exhibition, demonstration in precise measurement and quality control and related parameters. So in many spheres of human endeavors, from science to business, business to education, education to economic policies, good decisions always depend on good measurement. That is the quotation by Ben Bernanke. So when we go for the metrology usefulness, so metrology is a foundation of 3S, science and technology, seamless trade, and standards. And when we go for the sensor for manufacturing, this sensor, three pillar, 3R3M, modern manufacturing, metrology, and machine automation. And if you see the downward slide, you can have metrology with 3S, science, technology, seamless trade, and standards, and sensors, modern manufacturing, measurement, and machine automation. This metrology point gives economic growth, and the sensors growth gives you technological growth. Both together give accelerated growth, and it will give countries growth. And our dreams of becoming third largest GDP country. So recent advancement in metrology are in nanometrology, quantum metrology, 3D metrology, digital metrology, IoT, and AI metrology. So digital, I have a little bit, I have to discuss digital metrology, calibration and traceability, data management, software and firmware update, capabilities, comparability, training and expertise, and cost. So challenge in digital metrology, calibration and traceability, data management, software and firmware updates, training and expertise, and cost. So now digital certification is focused in all the countries are working on this digitalization of calibration, so that one can have their calibration at site using SI traceable measurements. So these are the aspect which in digital certification, if some of the student find it interesting, they can work. This a very new challenging field, which is based on fair digital data concept, which is data findable, accessible, interoperable, and reusable. So that is through administrative data, measurement result, administrative data, a lot of data collected, and this management and the security and all this, and measurement results through SI system. So software application being used in digital calibration certificate, various packages are available. CAC-PAC, MatCal can be used, Pro Cal V5, Calman, Fluke Mat Team, and many other are also available. I am not recommending any of this, just collection of few important software tools. NMI software application being used for digital calibration, for measurement and data acquisition, data processing and analysis, calibration, certification generation, digital signature and security, storage and distribution. These are some flow chart for the interesting student, which can have administrative data type and material data type certification and all this few measuring equipment, collecting data and all this. So future of metrology is basically for the health, security, and safety of growing population with evolving social attitude and values. So it enterprise digital innovation to increase prosperity, productivity, and growth, and also to enable equality and fairness. So reduce human impact on the climate and management of natural resources. So how it can do? Metrology will support a digitally enabled global measurement infrastructure, improve understanding complex system, and give confidence in decision making. So metrology support system-based understanding. Metrology will give confidence in decision making. I have clearly and very elaboratively prepared all these slides. Traceability chain to be shortened, therefore reducing uncertainty. Traceability to SI units enabled directly to measuring instrument. In situ calibration of sensor and local standards will be compared. Support system based, complex system understanding, because huge data, so system will be more complex, so that way understanding. Decision making. Focus area in future will be again environment, energy, food production, healthcare, manufacturing, and transport. So I will give only detail of Is it visible? Hello?
Yes, sir. Visible, sir.
Or only 5-10 minutes.
Okay, no issue, sir. Take your time, sir.
So I will read this particular, some of the people will be interested. So demand for energy will continue to increase as our society becomes more digitally connected and integrated, which will put pressure on resources and security of supply, increasing global tension and economic pressure for innovation. So energy production infrastructure will become increasingly resilient, robust, and efficient, as well as more decentralized and operating under new business models. So energy system and energy use will change significantly in response to climate change targets. supported by proactive evidence-based legislation and education to help change consumer behavior. So in energy, measurement will enable new, innovative and low carbon energy generation technology, next generation of low power, low loss electronics, communication technology and computer systems, underpin the development of evidence-based energy policies and regulations, and support the evolution of social values on energy use, enables decentralization, maximize efficiency, and ensure AI-enabled smart grid infrastructure, and are needed to ensure accurate and fair energy sale and purchase of enable demand-side responsive program. So this is a very, very important futuristic metrology. Another important is food production. I would like to read that also, because when we are becoming a developing at the moment developing country, but moving towards developed country, our population is also increasing. Also, for a rising global population, is increasing demand for food and water. For every aspect, more choice about their food. So more efficient and automated food production, both through agriculture and the manufacture of food substitutes, will require to meet demand. So food retail will be primarily online, which is happening today, benefiting from automated and zero carbon delivery methods with food safety guaranteed by sustainable and smart packaging. This is a very, very important and a challenging task one can take. So again, I read food retail will be primarily online, benefiting from automated and zero carbon delivery methods with good food safety and guaranteed for sustainable smart packaging. So all this measurement will help enable tracking throughout the food production and distribution, help eliminate unnecessary disposal of food, increase the sustainability of packaging to support the circular economy, and enable sustainable efficient distribution, provide confidence in the automation and process engineering, ensure food safety and crop resilience, and needed for control nutrition and function, and design food to tackle diseases. So this is very, very important challenge. Healthcare is another. So I'm not going all this again and again. So role of metrology, if I read in a nutshell, no quality without quality control, no quality control without measurement, no measurement without calibration, no calibration without accreditation peer review, no accreditation peer review without traceability, no traceability without measurement standards, and no measurement standards without metrology. So this you can clearly understand my message. Metrology is of utmost requirement for national economic and industrial growth. It supports development of primary and reference standard, national system of measurement. It facilitates international harmonization and compatibility of measurement results, are responsible for apex level metrology. This I can leave. Thank you.
Thank you so much, sir, for giving this wonderful talk. So, is there any questions from the participants? Any question from the participant side? The forum is open to you. So no question from the participant. Sir, I have one question, sir.
Ji.
Sir, as you discussed about that the implementation of EIML in the metrology and measurement system, sir. So how it can be implemented like that?
How can be implemented? It's a very simple. The measurement you are performing, you have to have those measurement, repeated measurement. So when you will repeat, suppose it will tackle two problem together when you perform the repeat measurement. Suppose in one measurement, it is giving 24.24, and another measurement it is giving 24.36. So that is a repeated measurement. So you can clearly determine the difference in values. But it can also tackle the mistakes by the operator. Normally, operator can do that for 24.36, he can write 24.63. So that is possible. So those problem of things can be tackled through automation, calibration, and measurement should be traceable to certain standards.
Okay, sir. Thank you, sir.
Yeah.
So let's wind up this session here. So on behalf of Department of Electrical Engineering, JC Bose University, YMCA Faridabad, I, Dr. Abhinav Saxena, would like to extend our sincere gratitude for your insight and engaging session during the FDP. Your expertise and clear explanation and real-world examples greatly enhance the learning experience for all the participants. Your talk has undoubtedly inspired the new perspective amongst the faculty members and research holders. We truly appreciate your time and effort you dedicate to prepare and delivering our valuable sessions here. Thank you once again, sir, for your contribution to the success of our program. We look forward to you for the opportunity for the collaboration with you. Thank you so much, sir. Thank you.
Thank you. Hope I have justified this few hours.
It is really worthful for all the participants, sir.
Thank you, sir. Thank you.
Thank you, sir. Sir, one minute, sir. Sir, let's have a group photo, sir.
Yeah.
Vinayak, are you there?
Yes, sir.
Okay, so a group photo kar lete hain. Now I request all the participants, please switch on your camera first. Please switch on so that we can have a group photo. Vinayak, once it is done, please let me know.
Yes, sir.
Have you taken? Okay. Thank you all the participants and thank you so much, sir, for giving your valuable time, sir.
सक्सेना साहब मुझे भेज देना एक बार फोटो.
हाँ, sure, sir. मैं भेज दूंगा सर आपको, पक्का सर.
Thank you.
I'll give it to you. Thank you so much, sir.
Okay.
So I request all the participants, please stay connected. By the time our next speaker is going to join very soon, so it is requested to please stay connected, and your this feedback form will be shared on your respective WhatsApp group.